For number 1, we're going to encode the word mongoose using a Caesar cipher with a shift of 3. Now, to start doing this, one way you can do it is to write out your alphabet A through Z, and then below it, write shifted 3 forward. So below A you would write D, below B you would write E, and so forth. And I'm going to, instead of writing it all out here by hand, I'm going to just add a picture. So here's my picture with the plain text along the top, so that's your regular alphabet, and then the disguise text is what we'll change this into. So for example, M, if you look in the top row, so look along the top, you find M, that's going to get changed to P, and so forth. So we end up with P, and then O is going to be changed to R, N is going to be changed to Q, G is going to be changed to J, O is going to be changed to RR, S is going to be changed to V, and E is going to be changed to H. So it's pretty easy to do. What you really have to keep in mind is which line you're looking at. See how I write plain text here because this is a word that we can read. It's the word mongoose. If it was disguised text, like we'll have down in number 4, then you would look along the disguised text to find the letter and then see what it would be changed back into on the top. And in fact, we can do that right now. So let's take our plain text here and let's move it down to here. Our plain text and disguised text together. Let's move it down to here, and let's focus on number 4. Now this is a disguised message, or disguised text. So what's going to happen? Well, we look for J along the disguised text line, and that's going to be changed into G as a plain text letter. So G, and then we look for R right here. That's going to be changed to O. So we get an O twice. And then G is going to turn into a D. And then M is going to turn into a J. R will become an O. And E will become B. And if you do this right, if you start out with a disguised message, then you should always end up with something you can read when you get done. And this makes sense. It says good job. Alright, so we've done a Caesar cipher with a shift of 3 where we encoded the message in the first one, and in number 4 we decoded the message. Okay, so let's go down a little bit further here, and well, I can get rid of this for the moment. And then let's go down and look at number 7. Well, this has a shift of 10. So we can do the same thing we did before, but now the disguised text will be written below the plain text alphabet with a shift of 10. Okay, so I have my plain text and disguised text together here for number 7. And notice I have a shift of 10 because below A for the plain text alphabet, right here, I have a K written below it, 10 letters forward in the alphabet. And then the rest you just go in order writing out the alphabet. Okay, so Voldemort lives. We want to change that into a disguised text. So we have to find our letters V, O, L, etc. along the top and see what they change into on the bottom. So V is going to change into an F. O is going to change into a Y. L is going to change into a V. D is going to change into an N. E becomes O. M becomes W. O becomes Y. R becomes B. T becomes D. L becomes V. I becomes S. V becomes F. E becomes O. and S becomes C. Now, when you're doing something like the quiz or the final or other worksheets, sometimes it'll give you additional instructions, like write the message with chunks of 4 letters at a time. And so what you would do is you would first write it out like this, and then rewrite it where you would do something like F, Y, V, N, and then a space, and then O, W, Y, B, space, D, V, S, F, space, and then it looks like OC. And so that would be your final answer if it gives you instructions like that. Or it might say write it in chunks of 3 or chunks of 5. So just be careful to read the instructions for the problems. Okay, what about number 9? Let's skip down to number 9, and you can do the ones that we're skipping on your own. But for number 9, we want to decode using a Caesar cipher with a shift of 11. And so again, I need to add in my plain text and disguise text so that it's easy to do this decoding. Okay, so now I have my alphabet in there and then the disguise text below it with a shift of 11. And now remember, I have a disguise text this time, or letters that don't go together to make words, and so I'm going to look along the bottom and then see what it should be turned into by looking at the top. Okay, so C along the bottom, you can see gets turned into an R, and then Z gets changed to O, D gets changed to S, P gets changed to E, M gets changed to B, F gets changed to U, and O gets changed to D. Now if you do that, it should make a sentence or a phrase or words, and make sure you write the words with the appropriate spaces. Don't just have them all to run together, for example. Okay, so that's number 9, and you can try number 10 with a shift of 23 there on your own. Okay, so now let's move down and look at the bifid cipher, and we're going to do number 11, where we encode a word, and then we'll look at number 13, where we decode a word. The first step to doing a problem like number 11 is to make a Polybius square based on the keyword. And remember, that's a 5x5 grid where you write the word Superman, skipping any repeated letters if there are any. In this case, there's not. And then you fill in the rest of the alphabet in order, not using any of the letters that you used in the keyword when you wrote it in. Now I'm going to just import a picture here. Okay, so I have my Polybius square that I imported in. And notice that if you were doing this by hand, you would just start by writing the word Superman. There were no repeated letters there. And then, since A's been used, you start with B, and you just start writing them in alphabetical order, skipping any that have been used in the keyword. And there's also one other change. Notice that J is not used in the keyword, but I also skip J down here. I go from I to K because J never appears in the Polybius square. We skipped it in this case. If it happened to be used in the keyword, you would first change that J to an I, and then you would write I in the keyword part instead of J. So J never appears in the Polybius square. Okay, so once we have that Polybius square, we now want to encode this word kryptonite. So how does that work? Well, here's what you do. You find each letter of the word you want to encode, and you find it in the square. So K, for example, you see has row, which is right here. You look for the row, which is 4 in this case, and then you match it up with column, which is 1 in this case. So it's 4, 1, right? And so the way you would write that would be a 4 and then a 1. Okay, so you write it like that. Now, one thing that I should mention is to do this correctly, you do have to keep row and column in the right order. You wouldn't want to think of this as column and this as row, or it's going to mess things up. So row, column. I had a teacher once who always told me to think of Roman Catholic for row, column, and for some reason that's always worked for me, so it might work to help you remember that row is here and column is here. Okay? Okay, so let's go through and do this real quick. We have for 1, what else do we have? Find R. We have a 1, 5. Y. We have 5, 4. P is 1, 3. T. Let's see, where's T? It is 4, 5. O is 4, 3. N is 2, 3. I is 3, 5. T is 4, 5. And then we have one more. E is 1, 4. Okay, so we have our pairs written. Now what we do is we take this bottom and we append it to the end of the top. And so you end up with something that looks like this. 4, 1, 5, 1, 4, 4, 2, 3, 4, 1. That's the top row. And now you have the bottom row appended to it. So it's going to be 1, 5, 4, 3, 5. I'll give myself a little more room here. Move that over as well. Alright, so we have 1, 5, 4, 3, 5, 3, 3, 5, 5, 4. And now what you do is you take these a pair at a time, looking left to right. So for example, we have 4, 1 paired together, 5, 1, 4, 4, and so forth. And now turn that into a message, and what do you have? Or translate these back to letters. And remember, the 4 is the row, the 1 is the column, and then 5 row, 1 column. And so we have rows and columns. So we have 4, 1. Looks like that becomes a K again. 5, 1 becomes a V. 4, 4 is a Q. 2, 3 is an N. 4, 1 is a K. 1, 5 is an R. 4, 3 is O. 5, 3 is an X. 3, 5 is I, and then 5, 4 is a Y. Alright, and so that is our encoded message. KVQNQROXIY. And again, read your directions for how that might want you to write it in chunks. It could be in chunks of 3, so KVQ space NKR space, etc. Or it might have chunks of 4, or it might ask you to write it in chunks of 5. Okay, so that is the word kryptonite encoded using the Bifid cipher with keyword Superman. Okay. Well then, let's go down here and look at number 13. You can do 12 on your own. Let me erase some of these things we're not using now. All right. Okay. so let's come down here and look at number 13. Now here, again, the first thing to do is to make your Polybius square based on the word Batman, and I'm going to import my picture. Okay, so I've got my picture imported, and now remember that this is a message that we want to decode. So what we're going to do is, again, we're going to find these letters. So for example, T, you want to find down in the Polybius square, and you'll notice that the row is 1, column is 3. But this time we want to write it left to right. So for example, we're going to write 1, 3. And then E up here. Right? So E is going to become row 2, column 3, so that's 2, 3. K is going to become 3, 3. F is going to become 2, 4. H, 3, 1. I, 3, 2. X, 5, 3. And then K becomes 3, 3. Alright, now there should be an even number of digits here. So what do we have? 2, 4, 6, 8, 10, 12, 14, 16. So you take the first 8, and we're going to divide right here. And we're going to take the last 8, and we're going to put them underneath the first 8. So it's going to look like this. 5, and then 3, 3, 3. Alright, so this is what we'll focus on now, is right here. And we have these pairs, so a row and a column, a row and a column, and so forth. And we're going to turn those into letters now. So 1, 3 is going to become T, and then 3, 1 becomes H, 2, 3 becomes E, 3, 2 becomes I, 3, 5 becomes O, 3, 3 becomes K, 2, 3 becomes E, and 4, 3 becomes R. And at first you might think that doesn't look like much, but remember that first you have to separate the words, so the, and remember that J's get replaced with I's sometimes. So if I-O-K-E-R doesn't make sense, try a J, and then you'll see that you actually get a message. The Joker. So that's this guy right here, decoded using the Bifid cipher with keyword Batman. Now you can try a similar thing down here with number 14 on your own.